Do you want to make games in C++ but you just can't start? Today you'll make your first C++ game with a 3-step tutorial, so you can finally progress towards making those cool projects you have been dreaming of. No more excuses, you just have to sit down, watch this tutorial and code. The best way to learn is to practice, so once you have this simple snake game working, you will be able to practice some more on your own, and eventually level up to GigaChad C++ developer level. Prerequisites. Before you make your first C++ game, you obviously need to have a decent understanding of C++. You don't need to know advanced C++ features. In fact, I recommend against getting there. But you need to understand things like pointers, functions, structs, and basic C++ utilities, like the std vector. And also, you should be able to use them on your own to make a small program. If you are not on this level yet, just watch any C++ tutorial series on YouTube, but make sure you code along. But once you have a basic C++ understanding, we can get into step 2, and that is configuring our library. In order for you to draw stuff on the screen, you need a library that draws stuff on the screen. For this, we are going to use Raylib. It's super easy to use, and it has the best documentation there is. Look at how many examples they have. And the best part is that you can just copy this code and try it locally. So, while we will be making a super simple game, you can even do 3D stuff. But before we can use this library, we need to configure it into our project. And this is where all programming tutorials will teach you how to link this library, and I'm completely against that. Linking in C++ is hard, unfortunately, and if you just copy-paste some steps you see in a tutorial, you will basically learn nothing. So you will just waste your time, not to mention that if you do a single wrong thing, nothing will work. So most beginners get stuck here. So in my description, I linked my setup that already configures Raylib for you. My recommendation is to use it like this for now, and later learn how to configure these things yourself by watching this video. But for now, let's just learn how to use my setup. I use something called CMake, and it basically creates a project that can be compiled with any compiler and on any operating system. Now I will explain how to do this on multiple compilers, but if you're on Windows, I strongly recommend you use Visual Studio because it has the best debugger and also a super good profiler. I know it is laggy, but you can just install an older version and it will run very well, and I bet you don't care about their newest AI features anyway. So I will link the installation of Visual Studio 2017 in the description. Now make sure you have this desktop development component installed in Visual Studio. You can find this in the Visual Studio installer app if you already have it installed. Make sure you have it installed, because it doesn't work without it. Now opening the project is super simple. After you downloaded the project and placed it somewhere on your PC, right click inside here and select Open with Visual Studio. If you can't see that option, you can also enter inside Visual Studio and click Open CMake. Now you can press Ctrl plus Shift plus B to build a project. And from here, you can select mygame.exe. And now, if you press Ctrl plus F5, the game should compile and run. Now let me teach you how to solve some common errors. If this didn't compile, first make sure you have this component installed. Then go inside CMake and press Ctrl plus S to refresh it. Finally, if you still have weird problems, you can rebuild the project from scratch by deleting the out folder and press Ctrl plus S on the CMake again. Now, if you still have weird errors, you should read the error messages in the output. I have no idea why, but beginners just literally don't look at the error messages. Read this carefully, and if you don't understand what it says, ask ChatGPT for help, or you can also join my Discord server and ask someone there. Next, to add new files, you just add the CPP files here, and the header files here. When Visual Studio asks you this, click No. Next, to make a release configuration, go here, and add a x64 release build option. Ctrl plus S and close this. Now you can switch between debug and release. Now let's quickly cover how to run my setup in other IDEs than Visual Studio. For CLion, it's quite easy because it already uses CMake, so you should be able to just open it as a project directly. For Visual Studio Code, you need to install CMake, and then install the C++ and the CMake extensions. After that, you should be able to just open the folder in Visual Studio Code, and it will ask you if you want to configure the CMake project. Select My Game, and now you can compile it. Now, another quick option to create a CMake project for a compiler is to do it manually, but I don't recommend that, because it won't have good integration with your IDE. But it works like this: don't use this CMake tool. Instead, inside the project folder, make a new folder called build, and inside, open a CMD. Type CMake ... and this will generate the project for you. I don't like this though, because you need to repeat these steps every time you add a new file. Now you should have this compiled and working, and I know you probably don't understand the code, but don't worry, we will get there. There is only one more thing you need to know about my setup before we move on, and it has to do with resources. So your game will have things like textures and various other assets. You place all of those in this resources folder, and every time you want to access resources from this folder, you use this macro that points you directly to the resources folder. But when you want to send the game to others, you need to go inside the CMake and do this change here. This will set the resources path macro to point into the same folder as the exe file. Also, you want to change this to release probably. Now, with these changes made here, press Ctrl plus Shift plus B, and now you can take the exe file and the resources folder and copy paste them into a folder. Now you can place this in a zip archive and send it to someone else. If everything is working, we can move to step 3. So delete the content of the main file, so we can start from scratch. I know you can't wait to start coding, but we just need to quickly cover some theory about how coding a game works. Making a graphical application is a little bit different than making a console application. For a graphical application, like a game, you want to have this window, and you want it to respond to your inputs. So while a console application is usually written very linearly, you do something and then the application closes, a graphical application has to remain open and update according to your input. So to keep this window open, you will create what is called the main loop or the game loop. This is an infinite while that only closes when the window closes. Inside this while, you want to draw to the screen, handle the game logic, and respond to what are called events. What are events? So the operating system will let you know every time something has happened to the window, like it received key presses or it was resized. And you need to acknowledge those messages, regardless if you do something with them or not. Let's look at a full example. Say you want to draw a square moving on the screen. Well, inside this while, you'll clear the entire screen to black. Then, you will draw the square, and then increment its position a little. This while will run something like 60 times per second, and get you this result. There is more to talk about, but for now, let's open a window. First, we need to specify some flags for the window, like for example, that you want it to be resizable. Next, you call init window, give it a size, and a name. Now you need to make that infinite while loop that I told you about, and it will stop when the window should close. That means when we click the X button on the window. Now, in order to draw to the screen, you need to call these functions, begin drawing and end drawing. And you do your drawing inside them. We clear the window to a white color so we can draw over it, and then we draw some text. These parameters are the positions, size and color. Don't worry, I will explain them in just a second. Finally, outside the while, we close the window, and that's it. If you run your program, you should be able to see something like this. Okay, now let me explain you how the coordinates and the colors work. So the coordinates are in pixels, and they start from the top left corner. So that first pixel is 0 on X and 0 on Y. So to go to the right, you increase the X component, and to go down, you increase the Y component. It is a little weird that you increase the Y component to go down, but this is how things were a long time ago, with old TVs that updated the pixels from top down. Anyway, if we let's say change this draw text function a little to draw from 190 and 50 and run the program, you can see that it started 190 pixels from the left and 50 pixels from the top of the screen. Now let's look at the colors. These things are some constants, and you can supply any color you want using a struct of 4 components. If you don't know already, colors are stored inside the computer using 3 components, plus 1 more for the opacity, red, green, blue, and alpha for opacity. Combining them, you can get every color. Raylib stores colors inside the color struct. Inside this struct, each component is stored as an unsigned char. So for example, this color has the maximum amount of red, because the max value for an unsigned char is 255. It has 0 green and a lot of blue, but not all the way. Finally, the A component is alpha, or opacity, and if you make it a smaller value than 255, it will make that object transparent. Let's try displaying this color. Now, you don't have to write all of this every time you want to use a custom color. You can actually easily write it in place. This is how you do it. Now that you have a rough idea of how Raylib works, we can start coding the game. Also, if you like how I explain things, this last part of the video was taken from my C++ game dev course, that is basically like this video you are watching now, but 6.5 hours long, and better. So link in the description if you want to make your first big game, and it might have a special discount. Now let's actually start making the game. We are going to make a simple snake implementation, and we are going to draw it using this grid that you see here. So I will first make some constants to represent how many cells we have on X and on Y, and also the size of one cell. There we go. Notice that the window can't be resized, because we didn't pass the resize window flag to it. Next I'll make a helper function that we can use to draw a cell. So we want to be able to specify what cell to draw and what color. Here is the function. First we specify the position in pixels, so this is just the cell number multiplied by the cell size. Then we have the cell size on X and on Y in pixels. And finally we have a color. So for example, we can draw some cells here. This one will be in the top left corner. Remember, that's where 0, 0 starts from. And this one will be 2 cells to the right and 1 cell under. And this is the color. This is the result. Notice that every frame we clear the entire screen to black, and then we draw on top of it. This might seem redundant to redraw everything every time, but this also allows games to be way more complex. So that's how we make them. Okay, so now I want to draw this checkered pattern. First I clear the screen to a dark gray. Then I'm going to make a for loop and iterate over the rows and columns. Next I will use this simple formula that will give us the checkered pattern and draw cells with a slightly lighter gray, and we get this result. Next we need to start working on the snake. The snake is made out of multiple pieces, but you should make things step by step. So for now, let's store a single cell of the snake. For this, we are going to use a vector. A vector is simply a struct with 2 components, X and Y. So inside it, we can store the X position and the Y position. So we have the snake position, and then we draw it in green after we draw the background. That's important. We want the snake to be on top of the background, and this is the start of our snake. Next we want the snake to move, so we need to somehow specify a direction. The snake can move up, down, left or right, and some people would just define some constants for this. But let me show you a different idea. We are going to store the direction in a vector. For example, this vector has 1 on X and 0 on Y, and all we have to do is add this to the snake position. So this will move the snake right, because we add 1 on X. But if we run the code, we won't see the snake. Can you figure out yourself why this code broke the snake? The code is actually working, but it's working too well. Because we move the snake by 1 cell every frame, the snake is moving way too fast. So fast that it simply leaves the visible game area before we even have a chance to see it. So we need to add a simple timer to make sure the snake moves slower. Implementing the timer is quite simple using the delta time. What is delta time though? So remember that we have this infinite while loop. One iteration of this while is 1 frame, and ideally we want to have 60 of those a second or more. So when a game is running at 60 frames per second, it means that this while is executed 60 times a second. Delta time is the duration of 1 frame, and it's measured in seconds, and Raylib has a function that gives us the delta time. Usually in games, it's used when something is moving. You multiply the movement by the delta time to get a smooth movement. In our case, we will just use it to make a timer. So every, let's say, 0.2 seconds, we will move the snake once. First I will make a constant to represent how long it takes until the snake moves. Next I will make the timer. Every frame we will decrease the delta time from this timer, and because delta time is in seconds, it's super easy to specify time. So in this example, the timer will take 0.2 seconds to run out. After the timer runs out, we reset it by adding the timer duration. And now we can move the snake. This code will make the snake move only every 0.2 seconds. Now this is much better, but the snake left the game area. So let's make it wrap around to the other side of the map when that happens. The code is super simple. If the snake left the map on X, we place it on the other side. Same on Y. And if the snake left the map from the left side of the map, we place it to the right side of the map. This is the result. Okay, now let's work on adding the fruit. The fruit needs to spawn in a random position. That is not the player. Fortunately, Raylib gives us a simple to use random number generator. So let's create the fruit position, and also a function to randomly place the fruit somewhere else. Remember that the fruit needs to pick a random location that is different from the player's location. So I'm going to make a super dirty implementation that is not great, but it gets the job done. So I'm going to make a while, get a random fruit position, and if the position is different than the player position, we break the while loop, else we try again. Now don't forget to call this function before the game loop. And also, let's draw the fruit after the player. And if we run the code, we can see that every time we get a different fruit position. Now we need to upgrade our snake from a single cell to a real snake made out of multiple segments. This is the plan. We are going to use a vector of vector 2's to store the snake. The head of the snake is at position 0, and the rest of the segments are just pushed back. When we move the snake, each segment, starting from the last element, will just take the position of the element in front of it, and the first element will just move in the direction that the player inputs. For this, we will refactor the code, and this is actually easier than you think. Because C++ is a statically typed language, it will give us errors where we need to change the code. So I will replace the snake pose by a snake vector, and delete the snake pose. Now the compiler will complain, but all we have to do is fix the compile errors, and everything will be working. First of all, let's add the first element to the snake vector before the main loop. Next, the setFruit function will need to check if any body part of the snake touches the fruit. So this is how I would do it. As you can see, if no body part touches the fruit, we can break out of the while loop. Next, we need to draw the entire snake, not just one cell. Same for wrapping the snake around. We will take the same code, but we will just apply it to the entire snake body. Now, moving the snake is a little bit more tricky. So again, starting from the last element, each element will take the place of the next element, and the head of the snake will move in the direction that the player specifies. This is the code. So starting from the back of the snake, each element takes place of the element before it, except the head of the snake. That will move in the direction specified by the player. So now, if we run the code, everything should be the same. But if we manually add some more elements to the snake, you can see that they will follow the head correctly. So let's add the player controls. Raylib gives us some super easy to use functions that tell us if a button is held. So the code is super simple, but be careful where you place it. We can't place it where we move the player, because that code only runs once every 0.2 seconds. We want to always check for key presses. If a player quickly presses a button, we want that to always get registered. And now, we can control our snake character, but we can't collect the fruit. So let's do that. So after wrapping the snake around, we check if the head of the snake is at the same position as the fruit. If so, we set a new fruit position, and we add a new element to the snake. We can just add it to the same position as the last element, so it will overlap the end of the tail basically. But if we run the code, you can see that this works super well actually. The only thing left to do is implement the snake colliding with itself and resetting the game. But before that, we have a small problem. Can you figure it out yourself before I tell you? The problem is that I can set the snake move in the opposite direction, and that's not okay, because it will hit itself. So we need to make sure that the new position we set the snake to is not opposite to the last position. To solve this, we will create a new variable called new direction. Now, whenever we press a button, we set the new direction. Finally, when we actually move, we check that the new direction is not opposite to the last direction. If it is, we reset the new direction. Finally, we set the direction and we move. Now let's detect when the snake hits with itself. We want to detect if the snake head hits any other part of his body. But there is a small problem here. Remember that when we add new parts of the snake, we actually first place the new segment in the same place the last segment was. This could trigger a game over for the first fruit we eat. So we need to be careful how we do things. In order to avoid this problem, we will check if the snake hit itself after it moved, and also after it wrapped around. So we will move the wrapping around logic inside the movement code, and write the collision code after. If any part of the snake hits the head of the snake, for now we will print game over. Let's test it. Finally, let's reset the game when the snake dies. One pattern I like to do is to take everything game logic related and place it inside the single struct. In this way, I am more organized. So let's do this. Note that this will still be kind of messy, so I have this video about how to better organize your game structure that I highly recommend. Now I'm going to move everything game related into this new struct, and I'm also going to move some of the functions inside, and also create a reset game method. You can also make an update method, but again, I recommend you watching this video to see a better way of organizing code than what most people do. Before I talk about the bonus step, how to continue from here, for a longer game in C++ tutorial, I have a full course that is literally just like this video, but 6.5 hours long, and you also get 50 plus challenges and bonuses, and we make together a full Terraria-like game. So link in the description, and it might even have a special discount, so go take a look there. Bonus step, how to continue from here. Now from here, there are many things you can do, like you can as a challenge, make the snake, also have a checkered pattern. If you ever need help with Raylib, you can check their documentation, or even ask ChatGPT. And remember that if you want to load custom textures, you need to place them inside the resources folder, and use the resources path macro to open them. Now I recommend making more and more projects that are bigger and bigger. And please, stay away from theory books and how to design software books. Most give bad advice, and it's way better you just write simple code instead. So you can check out JVDX9 channels for this, because he has some super cool projects for you to try. Also, you can check out my channel as well. Like in this video, I explain how to more nicely organize the main function. See you!